This is a deep dive into front-end web performance, and check out the animation. So we're gonna, let me just give you an overview of what we're gonna talk about here, and then you can all walk out. So we're gonna talk about why you wanna make your web page fast and what that even means. We're gonna give a quick rundown on how browsers work and how to measure your performance. And more in-depth rundown on how browsers work and tips and tricks to optimize each of those stages that we would have talked about. So yeah, so this is me. My name is Mike Herchel. That's my daughter, and that's my new puppy. His name is Dexter. He's pretty sweet. Not pictured here is my other dog, Coco, who we don't love. I work for Lullabot. Lullabot is a strategy development design agency. We're all distributed. We do cool websites and stuff. Yeah, stuff and things. So I have this coworker who asked me, he said, Mike, why do web pages need to be so fast? And this is a legitimate thing that he asked me. And I said, Matthew, can I put your picture in my slide deck? And he said, sure. So, Matthew tiffed, well, 53% of all mobile site visits are abandoned if a page takes long, and I think we've all done that. If a page is taking a long time on your phone, you're just like, F this. This is a chart given out by Walmart.com several years ago, and this is the page speed right here. So if the page speed is very high, hold on. No, this is the conversion rate. The conversion rate's very high, and this is the page speed. So blue is the population, conversion rate, and load time. So as the conversion rate's very high, when the page load time is very low. So like the conversion rate dramatically drops. You can kind of see this like little hockey stick type thing going on there as the page load time goes up. And so that's, when you're talking about a really big organization like that, that's millions and millions of dollars. But even for like smaller organizations, you're missing out on conversions, click-throughs, and all that type of stuff. You know, and the same thing is with ads. Ads, people are less likely to click on an ad if it doesn't take if it takes a long time to load. So like, yeah, so. But I feel like I already have you convinced that websites should be fast since you're like in the session. And if you didn't care that websites should be fast, you probably wouldn't be here in the first place. But if not, so what is fast? Watch this. Right there. All right, thank you, everybody. That's good. Yeah, so we're going to talk about so what does fast mean? So let's talk about front-end performance metrics. There's a couple of them we're going to be mentioning right here. So you have time to first byte, time to first meaningful paint, time to first interactive, and the speed index. And we're going to go over each of these. So the time to first byte, that's basically the time from when you like hit enter or you click on a link or something to when that first byte actually hits your browser, you know. So in order to do that, your browser has to reach out, might have to get like the IP address of the server it's reaching out to, has to say, hey, I want this page on it, you know, with maybe send these cookies, and then you get that first byte back. And that's what this measures right here. So any type of delay here typically indicates a back-end issue, you know, so we're not going to talk about optimizing this. But there are special things that you can do, especially caching, you know, especially when you're talking about server-generated markup, similar to what Drupal does. Usually, you can just cache the hell out of it, you know, whether that be in like Drupal's caching system or something like Varnish or a CDN. And if you can do a CDN, that's obviously really beneficial because it'll actually park your data closer to where your users are, and because we cannot exceed the speed of light. You want that data to get there as soon as possible. So when you're measuring the this type of stuff, the time to first byte is when you first see that like little graph go up. And I'm gonna show some profiling. We're gonna do some live profiling in a little bit, and hopefully the internet's working while we do that. And I can show you how to kind of do some basic performance profiling. But performance profiling, just FYI, is a lot of fun. Like, I like doing it for like other websites and just like to see, hey, what are you doing? Oh, and I don't know, it's just like deconstructing stuff. It reminds me of just like kind of the open web. You remember back when you first started, you could like view source and like make sense of a lot of stuff. You can do a lot of the same stuff now, but it's just like a little bit more complicated because you have to use developer tools. So anyway, that's an aside there. Time to first meaningful paint is a very important metric right here. This is actually when the primary content is visible, and it marks the paint event that follows the most significant change to the layout. So like as your browser's like building up the stuff, it's going to do what's called a paint event, and I'll talk a little bit about this in the future. And that first paint event that is actually like drawing stuff on your screen, that's what's called the time to first meaningful paint. It's a kind of a little bit, it could be an ambiguous target right now, but like when you're doing profile, you can enable the film strip view, and it'll actually show like where your it'll actually show you in the film strip view what the page looks like at any given point. So another metric that's super important is time to interactive. So have you ever like gone to a website, you know, especially on your mobile phone, and you can see it, and then you start hitting like the menu button and nothing happens, and you're like, what the hell's going on here? Is my phone locked up and stuff like that? No, your website is just not interactive. You haven't hit that time to interactive metric yet. And so that's like a really frustrating thing right there. So the time to interactive is basically when your initial JavaScript is finished parsing and your website becomes like workable, and you can maybe scroll and hit menus and do fun stuff like that, stuff that people actually want to do. So you can measure, when you're looking at your performance profiles, your time to interactive is basically over here, like after all the JavaScript is done parsing. The JavaScript is like usually in the yellow right there, and the purple is layout, but we're going to talk a bit about that. So you can take all those together and you build up this metric of what's called the speed index. And the speed index is something that's like, it was created by Google. The Google Chrome team has been doing like a lot of work on trying to make the web fast, and they're trying to they're trying to make the web fast because that's like Google's core business. You know, if the web is not fast, and like say like the apps win over the open web, Google's going to lose money. So they have a vested interest in this, as much as I want to believe that they're not evil. But let's talk about speed index. So it's a calculated value. It's kind of the average time at which the visible parts of the page are displayed. There's a hyperlink down here, and I'll post these slides up. But this link tells you actually how it's kind of calculated. But a way to look at it is like, how quickly does your page approach visually complete? And that might sound a little complicated, but like let's say like we have a couple different pages right here, like one on the top and one on the bottom, and they're both visually complete, say over here, but this one gets there a little bit quicker. Like you can actually start doing stuff up here, you know, while down here you would have to wait there. So the top row up here would have a higher speed index. And you can measure that in the audits tab of Chrome developer tools. And you can also measure it on webpagetest.org, and I will talk a little bit about that. So when we talk about order of importance, I like to think of the speed index like is pretty important, because it takes into account everything, and it kind of the way it does its calculations is it prioritizes everything together, and you know, it's just a way to, yeah, it's more holistic. The time to first interactive is one of my favorites, because if your website isn't interactive, well, you know, what the heck is your user going to do? So now I'm going to the point in the presentation where I'm going to talk a little bit about how browsers work, and then we're going to talk about how to optimize these stages and stuff. Does anybody have like any questions, or did I go over something too fast? And with that, I'm going to say no. So before I go any farther, like, let me just get a show of hands. Who here is a front-end developer? Who here is a back-end developer? Who here is just hanging out? Cool. Yeah. So like for the recording, everybody raised their hand when I said who here is just hanging out. So anyway, so the first thing, you know, your browser goes to the website. The first thing it has to do is just download that initial HTML file, you know. And as it's downloading this HTML file, before it's even fully downloaded, it starts looking at it, because it's trying to, your browser's just trying to make things as fast as possible for you. And then it starts prioritizing the critical content. Well, Mike, what the hell is critical? Well, critical is stuff that your web page needs before it can render, So something that it needs before it can render, it needs HTML, and it needs maybe some styles, and it might need fonts. And depending on how you structure your web page, it might need some JavaScript, So, prioritizing the content. So there's a couple different priorities right here, and I'll show you how to check that. So the highest priority is, of course, the initial document and fonts. Because by default, at least in Chrome and Firefox and Safari, your web page will not show unless you have your fonts. That's why, you go to a web page and you can see the background image, and then the content just comes in all at once sometimes. That's a flash of unstyled content, and the reason that you have that is because the web fonts are downloading, and then they get rendered in. And that's kind of bad because you want people to start reading your web page immediately. So you have fonts, and then you have your CSS, which is styling, So next on the line, you have any type of JavaScript tags that are in the head of your markup, and any type of network requests, like fetch requests or AJAX requests and stuff like that. Yeah. After that, you have script tags that might be below the footer. In Drupal, Drupal will put a lot of script tags right before the closing of the body field, the body tag. And the reason it does it is because when you place it down there, it will not block any type of rendering because it's medium priority as opposed to a high priority. And it's also not blocking any type of critical rendering or anything like that. After that, you have all your images coming in. So you can take a look. Who here has used Chrome Developer Tools? Yeah, right. So in Chrome Developer Tools, there's this column here called Priority, which is not visible by default. You have to kind of turn it on, and you can just right-click up on your columns up there and check that box to turn it on. And it's kind of cool because it allows you to kind of understand how the browser is actually pulling in your data a little bit quicker. So the next thing, of course, it pulls in all your data, and the next thing it does is it starts parsing and executing the JavaScript in your CSS, right? So anything that's in the head of the document, all your CSS and all your JavaScript, when I say JavaScript does not have either the async attribute or the defer attribute. It has to parse and look at all those before it actually renders the data. And which means before it's rendering the data, this is part of the critical path right here. So what we're going to do later, I'm going to talk to you about kind of methods on one of the ways to make your browser render faster is to not parse as much, not have it do as much work. And we can talk a little bit about that in a bit. So anything that's in the footer, or if it has the async tag, it parses synchronously, but it doesn't block the rendering. And so the browser parses the CSS, and it creates what's called the CSS object model. And basically, it's just a big object of your CSS, So you can kind of see that you would have a font size up here, and this would cascade, down to all these other nodes down here, and hence the cascading style sheet type there. At the same time, it's creating the CSS object model. It's creating the document object model, and the document object model is very similar, but it's taking the HTML and actually rendering all the different nodes, your DOM nodes in there, including any type of body tags, section tags, or anything else that are in there. It will take those and put those together, and it will create what's called a render tree. And the render tree is very similar to the DOM, except it will actually yank out things that are displayed none and stuff like that. And so this is kind of important because we talk a little bit, it does what's called the layout operation at this point, because it knows what it needs to build, but now it has to actually put it on the page. So it does what's called an operation called layout. Firefox calls it REFLOW, but it's basically the same thing. And the browsers look at each of these elements and they calculate, well, hey, this element needs to be 200 pixels by 400 pixels. This one is like this size. This one's inside the size. This one pushes this one over, and all that type of stuff. And that's kind of a really expensive operation, because it's a lot of thinking with a lot of DOM elements to put it all together. There's this cool video right here, and this video is it's a little old, but it shows the operation in an earlier version of Firefox, and it shows like how the browser's thinking as it's laying out the stuff. And that's something to keep in mind, like as it's doing it, you want to keep in mind like how many elements do you have on your page, which seems like kind of a silly thing, but if you get like over 3,000-4,000 elements, your browser can get a little bit slow, I'm sure we've all like encountered that. And especially if we're on like a slow computer. My computer, like this is a development machine, it's a lot faster than maybe a normal computer. But when you're thinking about performance, you have to think about, well, like my mom's computer, which has like malware and shit installed, and yeah. So it lays everything out. Your browser will lay everything out up there, but now it needs to like actually write it on. It needs to do what's called painting, and that's just basically the process of filling in pixels right here. So we're talking about like text, colors, images, borders. It's also a expensive operation, and the reason I'm bringing up that this is expensive is because there's various things that you can do when you're like, if you're animating or if you're bringing in like you're ajaxing in elements and stuff like that that will affect paint and will affect layout. If you can do things in a way where it doesn't cause relayouts or it doesn't cause repainting, your browser experience will be a lot smoother. Has anyone gone to a website where it has been like parallax, You ever seen those parallax websites? And as you scroll down, the website's going like that, And you're like, this is a horrible experience, the whole thing's jittering. But then sometimes you go to maybe another parallax website and you start scrolling and it's kind of silky smooth. And you're like, hey, this doesn't look that bad, It might be a little confusing, but it's definitely not like jittery. And the reason is because people are doing the same thing with different methods, And when you're moving stuff around, you typically want to transform them. And when I say transform, you're using the CSS transform property as opposed to animating maybe like the top, left, or background position property. And the reason is because when you're doing transforms, your browser can do compositing. So your browser will break up your different elements and stuff into different layers. And you can almost think of these as like Photoshop layers where you can like move them around on top of each other with relative ease. But if it's all one layer and you move something, you have to fill it in. And that's obviously way more difficult than just moving around if it's two different layers. Your browser will do compositing, and it's a cheap operation. It's done on your computer's GPU as opposed to CPU. And that makes things a lot cheaper and funner. So measuring performance is kind of cool, right? So this is another, I worked like really hard on like all these graphics with like the jet engines and stuff like that. I think they look pretty cool. And you can see that I put like all these like random like stuff in here like quantum CSS and lazy loader and JavaScript parser, but that's just all bullshit, of course. So we're going to demo some stuff, right? So let's demo some websites. So a website I like to pick on is Lullabot's website. We're in the process of changing a few things around right now, but I can pick on that. I can also pick on Drupal Camp Atlanta's website. Are there any Drupal Camp Atlanta organizers here? Yeah, all right, yeah, they're going down. And we can kind of see what happens here. So I'm gonna, let me Command F1 right here to mirror my screen. I'm gonna open up, oh, thank you. I'm gonna open up, I'm in Chrome Canary right now, and the reason I like, I always try to, when I do performance profiling, I do it like outside of like my normal Chrome instance, because I have like a lot of extensions. You know, I have like ad block extensions and password managers and all that type of stuff. And when you profile stuff, it'll catch that, you know, and well, you don't want to really profile an extension. So let's just do Drupal Camp Atlanta. And we're going to profile it. It seemed to be pretty quick right here, right? So the first thing I'm going to do is I'm going to go to the Audits tab. And you can select a couple different things. You can select mobile, desktop, and you can select how fast, no throttling or 3G. We'll just do no throttling initially. And this should come in pretty quickly. And it'll give us a score. It'll even show us like the speed index and stuff like that. And it'll say, hey, you're 63. These are some options that you can do. Your time to interactive is pretty slow. And it'll give you some information here. But what we really like to do is looking at the trace. So we're going to hit View Trace right here. And it shows us a bunch of really cool stuff. So you can see up here, it looks to me like the time to interactive is a lot quicker up here. So the time to interactive here is like right after this, which would to me means around like a little after a second or so. So what we're going to see is all the gray stuff are network downloads. I'm not quite sure. The blue stuff might be parsing. Yeah, parsing HTML. The yellow stuff up here is JavaScript. The purple stuff is layouts. And the green stuff will be painting and compositing. And so we can look at this stuff and we can say, hey, look, I can see that there's a layout event right here, a recalculate style and layout that's going on. But why is there a layout event over here? You know, why are we recalculating that? And you can, we can take a quick look right here and maybe see what's kind of coming in right here. Your network, it shows, let me back up right here. So this is also like the network as it's downloading right here. You can see a bunch of items download over here, then they download over here, and then they download over here. So we have this layout event happening right over here, and what's downloading directly before that, we might be able to figure it out. Ah, there's a font. So a web font is probably causing it to reflow. So I'm guessing that's font awesome, so that's probably the icons. And you can also maybe start looking at some of the JavaScript to see what JavaScript is happening here. A lot of times with this, you'll see like some Drupal behavior stuff, but sometimes it's a little bit difficult to parse through like jQuery if you're using that. But but sometimes you can like still kind of get an idea. We can also see right down here, there's what's called the script streamer thread, and what that is that's a concurrent thread going on where it's parsing another script, but it's not executing it. And right now, this is parsing. It looks like Google Tag Manager, which is like analytics and stuff like that. We can see there's a lot of JavaScript happening up here, and it's eating up probably like 400 milliseconds. So we can maybe take a look at what's happening here. So when you look at this type of stuff, you can see that like it's not how deep it is that's important, it's how long it is that it executes. So you can see like right here we're executing analytics. So there's some type of analytics. We got Google Tag Manager happening. I don't know so this looks like maybe Twitter type stuff, some embedded stuff. And yeah, so some of the issues that I would say on this is we could preload some fonts, which I can talk about in a little bit. And we could also, like, of course, like third-party scripts are obviously slowing this down a little bit. But the time to first byte over here is really, really low. And that's probably because they're either on a CDN or they're hosted somewhere here in Atlanta or somewhere close. I'm going to pick on lullabot.com right now just because it's kind of fun and there's some stuff in there that we're doing right and stuff that we're doing incorrectly. So some of these issues that I'm about to identify right here, they're all in the process of being fixed. We're in the process of redoing some of this, but I still like to pick on it. So the first contentful paint is pretty good. Everything else is, taking a little bit of time. Let's look at the trace right here. So some of the things that I see, right, if you look at this network that's kind of interesting, is I see that there is a big gap right here. So you have all this work being done right here. And if you look at like the screenshots down here, you can see like the main hero image is not filled in until you get over here, and then it starts like downloading, right? So you can see like all this information over here, and we have like this layout as the hero image is coming in. But like, what the hell is going on right here? Why is it taking so long for us to get that hero image? So you can see this right here. We got an API call, then we got another API call, we got another API call. We got like a chain of API calls. It's a chain of dependencies. So it's basically like one reaching out, asking a question, getting information, asking another question, getting information, asking another question. And all that's taking time because it's like round trips to the server, But outside of that, everything's pretty quick. Like you can see that, we're actually rendering the content. So I can tell you, like our current website is a React application built on top of decoupled Drupal, and we render the HTML server side. But that part that's, of course, not rendered immediately, that's rendered dynamically, so it requires those API requests currently. But the server rendered stuff happens like pretty quick, which is pretty cool. And so you can see like we're downloading like this very large JavaScript file which starts downloading immediately. And then, of course, we're starting to download all the images and stuff like that. So some of the things that I'm looking for right here is I'm trying to identify if there's multiple layout events or multiple repaint events. I'm trying to see if there's JavaScript that's taken a long time. And then I'm also looking for gaps. And then I'm looking to see why are there gaps. And a lot of things like that will tell you where your inefficiencies are and where the low-hanging fruit lies. Audits tab. I kind of went through the audits tab and performance tab. The performance tab is very similar to the audits tab, where you can get in there and you can manually start the performance by hitting like a red dot, and it basically shows you the same trace. I have this separate because the fact that you can view the trace from the audits tab is a relatively new feature. So network download. So what optimizations can we make on each of these steps right here? Like first of all, we can use less bandwidth, right? That's like an easy one. I think the average page weight of a website right now, a web page is something like 3 megabytes, which is like kind of crazy. Some of the things that can use some of the things that can cause this are large images. I've seen so many websites where, like one of the first things I do when I'm auditing like a website for performance is I look at large images, and it's really easy to do that. You can go to the network tab of, where's my mouse? Here we go. Let's go over here. You can go to the network tab over here, and you just, let me get to the all, and you just sort, you sort by size, and you see what's the largest size. Well, right now, I'm not. Let me refresh so we see it. So you sort by the largest size right there. So many websites I went to and I sort, and I see like, a whole bunch of JPEGs that are maybe like, a couple hundred kilobytes, and then I see a PNG file, which is exactly the same size, but it's like 2 megabytes. And like that's a problem, like you don't always need to be uploading PNGs. People are not going to notice. The only reason you would need a PNG is if it's alpha transparency, if you have like some type of transparency in there, and it's an older type of browser. What I try to do, if I know there's not going to be any type of transparency, is I just go into the Drupal, the content type, where the image field where you upload it, and I just remove the options for GIFs and PNGs. and then people have to upload JPEGs. And there's also modules like image cache options or image style options or something like that that'll do conversions for you. It'll use like the PHP GD and image something library and convert everything. What's that? Yeah, Image Magic and convert everything. There's a new image format called WebP. Has anyone heard of WebP before? So WebP is an image format. It was developed by Google maybe like 5-6 years ago, and it's kind of like the file size of JPEG, but it also has transparencies and has better quality. And Microsoft Edge and Firefox are now implementing WebP, and Safari will probably do it at some point too. And there's a WebP module for Drupal, and so you can convert your images on the fly to WebP through this module. And there is if you're using the picture tag, does anybody know what the picture tag is? It's like a responsive image tag. You can set the MIME type of that to like image/WebP, and then if the browser recognizes that, it'll just download it and work, and if not, it'll fall back to another one. I'm not going to demo that though, because I don't have it set up. So use less bandwidth, limit the use of large pictures, and use responsive pictures. Drupal out of the box comes with a responsive images module. And I wouldn't say it's easy to set up. I would call it's Drupal to set up. Where Drupal is the adjective where like once you kind of understand how it works, it's not too difficult. But if you're just coming in there and you're not looking at documentations, you're like, what the heck is this? So what that means is if you don't know what responsive images are, like if I have my phone, I don't want to have my phone download an image that's like meant for an iMac, because the picture that's meant for the iMac is going to be a lot bigger, So a responsive image will download the appropriate size image for the screen. And you want to limit your network requests. So like every single time that your browser like goes to a web page, as you all know, because most of you are web developers, it's composed of a bunch of different files, images, scripts, and CSS files and stuff like that. The less of these you have, the better, and that's especially if you're using, if you're not using HTTP2. HTTP2 is a newish protocol where it can kind of like synchronously download a bunch of stuff at once. Older versions of HTTP, like HTTP 1.1, only download 5, 6, or 7 at once. And I have like a little video that kind of demonstrates that. So what am I looking at right here? So, oh wait, this is just looking at some images, me sorting. So you can see I'm like sorting by this image right here. And this one image is a megabyte while the other ones are like way larger, right? I'll show you the other videos later. So another thing that's becoming very popular is something called the PRPL pattern. And PRPL stands for push, render, precache, and lazy load. So push critical resources for the initial route. This is basically like any type of, if you're using HTTP2, you can do what's called a server push, where it sends a header down with the initial document, and it says, hey, grab this CSS file and grab these font files too. So that's pretty neat. You render the initial route, which is basically like make it render the web page. Precache remaining routes, which is like anything that's on your web page, you can tell JavaScript to like start caching that. And then like anything that when you start scrolling down and other links come in, you can lazy load those in too. Something that does this out of the box that's like super awesome is Gatsby.js. If you've heard of that, it's pretty cool, and it can hook directly up to Drupal's JSON API module, which is pretty neat. So where we are here. So this, I think, is a video of HTTP2, right? Yeah, so you can see all these resources are coming in the network tab here, and what you're going to see is all the resources are coming down. When we look at the waterfall, they're like straight down, and maybe with like a little curve because they're kind of coming in synchronously. When this is rendering with HTTP1 right here. And you can see as it comes in, it's going to go boop, 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 boop. Where are we at here? Now we're going to go back over here. Is it moving or not? Yeah, so you're going to kind of see like it comes in and over and in, and it's like almost like a little waterfall effect as opposed to like a synchronous thing. So that's kind of the difference between HTTP 1.1 and HTTP 2. So if you can upgrade to HTTP 2, that would be awesome. There's a lot of CDNs, including CDNs like Fastly, and I think Akamai has built-in H2 support now. So if you're using a CDN, you might already have it. If you're using Pantheon, you have it because Pantheon uses Fastly CDN. This is limiting network resources. So this is a web page that I worked on a while ago. And if you look at the bottom right here, there's 356 requests. That's a lot, you know, that's a lot. And most of these, if you were to filter out the, if you were to filter out third-party stuff, it would only be like 70 or something like that. I even have like a little puke emoji for all those things. And it's like every little tracker, I think, is embedded in this website, unfortunately, including like NSA trackers and thought trackers and, you know, I don't know. So the resource hints are something that, if there's one thing that you can take away from the session and that you can start using today, it's resource hints. So resource hints are just basically like kind of like meta tags that are in the head of your HTML, and they tell your browser to do something before it knows it needs to do it. So what we can do is we can tell it to preload a resource, we can tell it to do a DNS prefetch, or we can do a preconnect. In reality, DNS prefetch isn't used too much anymore because preconnect kind of covers some of that. We're going to talk a little bit about this. So let's talk about preload. So if you were to, so what am I looking at here? I think this is like the Lullabot website right here. We're preloading the JavaScript file. And when your browser starts parsing the DOM and it starts looking at all this information, it has to make a decision on what to download. And sometimes it doesn't know that a resource exists. So in this case, we're downloading a JavaScript file because that JavaScript file is actually referenced in the footer, and it's a pretty big JavaScript file. I want it to come down immediately. But something else that we like to preload a lot is fonts. And the reason that we preload fonts is because when you normally are loading system font, or you're loading web fonts, you do it through your CSS file. And your CSS files are using @fontface, and then they reference another file. So in order for your browser to know about that, it has to, number one, get the initial HTML file. It has to download and start parsing to HTML. It has to download and start parsing to CSS. Then it has to look for the @fontface rules and start downloading those. So that's like a number of steps. That's like 3 or 4 steps before it can even start downloading these web fonts. And that's an issue, like that's why you see the text pop in like a second later after everything else on a lot of things. So you can see in this case right here, we're loading up the JavaScript, and then the fonts are coming in right here. So that's preload right there. We're going to put all this together in a little bit, but something I want to talk about now is preconnect. So preconnect is really cool if your website is reaching out to other domains. And this could be even something like if you're reaching out to like analytics.google.com or Google Tag Manager or something like that. So in this, what preconnect does is, number one, like if your browser reaches out to a domain, a couple things have to happen. It has to look up the IP address of the domain through DNS. It has to then establish an SSL connection to it, assuming it's using SSL, which most people are nowadays. And if you try to measure it, like a lot of times the SSL and the DNS lookup, I mean, altogether, this right here, if you can't see it, it's taken up about 400 kilobytes, or not kilobytes, 400 milliseconds. And so this is like time where the browser could be rendering stuff. But if you tell the browser to start connecting to it immediately before it actually like needs to reach out. It has that connection already open. It doesn't have to go through that SSL negotiation or DNS lookup and stuff like that. And you can easily shave off, 200-300 milliseconds off of your render time. So when you start putting things all together right here, you have like a whole bunch of different fonts coming in right here. And you can see over here, I also have a bunch of images coming in. These are hero images, and these hero images that I have right here would normally be rendered through like the background image CSS property, but that would have like a very similar penalty as the fonts, because the browser has to like start looking at the DOM, start looking at the CSS file, and then it needs to like figure out what it needs to download and all that. So I tell it to bring this all in immediately. And if you look over here, you can see like I'm bringing in multiple versions of the background image here, but I don't want to download all of these. There's this media attribute over here, and the media attribute will tell the browser which image to download, because the browser knows how wide it is and stuff like that. Something else that's kind of important is there's this cross-origin attribute to add on to the font tags. And the cross-origin attribute is important because if you don't do that, under certain conditions, the browser could download the fonts twice, which of course you want to prevent. So the cool thing about all this is inserting these into your head of your document. Is that difficult? You're nodding your head. No, shake your head. It's easy. You can easily just like edit your html.html.twig or html.tpl.php and start inserting this crap in there. And it will like literally render like a second or two earlier than it otherwise would have, You can see down here, I'm doing some pre-connects to some other things. Like I'm pre-connecting out to like some Google stuff and some Marketo stuff and Optimizely. This website had Optimizely and all this type of crap on there. So I'm doing that, and that shaves off some additional stuff. So the cool thing is like a lot of browsers support this out of the box, but you know what? For the browsers that don't, they just ignore it. So it's not like you're hurting anything, So yeah. So something else, we're talking about optimizing networks. We're still doing this. How am I doing on time? I'm kind of need to maybe start hurrying up. So I talked a little bit about chaining dependencies, like with those API calls, and also how the fonts are chained off of like the CSS files and stuff. You want to avoid that. Other ways that you can chain stuff are by like dynamically loading JavaScript. Dynamically loading JavaScript is typically not the best idea for web performance, because it does create that dependency chain, which is a lot of people will use bundlers like Webpack or something like that to bundle everything together, and at that point you don't have to worry about that. Yeah, here's that. Optimizing rendering. So some CSS optimizations. You want to avoid like base64ing images. Has anyone ever done that before? Like you can take an image and you can like base64 encode it and just like throw it in your CSS file, and the supposed benefit of that is that it saves a network request from you downloading that file. But the bad part about it is like that image would not be render blocking, but your CSS is definitely render blocking. So like you want to avoid that. You want to avoid those large style sheets. You want to split your style sheets up and only load them when needed. On modern websites that I'm working on, I tried to create a lot of libraries within my theme, and different libraries for different pages that load different things, so I can keep these CSS files very small and modular. And componentizing CSS files is just like really, really good in general, just because it just helps to organize your stuff. You typically don't want to worry about CSS selector performance. I know at one point that was something you had to worry about, but now your browsers are quick enough to do it. You can inline your CSS into your head. I can show some examples on that in a little bit. What that is instead of putting your CSS files into your head, you would actually put your CSS file into your footer, but then you would extract the CSS file that you need to render the initial like top of the web page, and then inline that into your head. And that, I don't know, shaves off, it could shave off like a couple hundred milliseconds or something like that. There's a tool called Critical CSS made by Adi Asmani, who is a Google engineer, that does that pretty good that I've had success with. And you can just generate your critical CSS file, do a twig include, and it'll just work. Yeah, split up your monolithic style sheets. Chrome Developer Tools has a coverage tool where if you go into, let me just show you really quick where that lives. I always hit, let me just show you the normal way. You can go over here and go into coverage, or right there it is, and then you hit record, and you start like navigating around the web page and stuff like that. And then you hit stop. I don't know, I might need to reload over here. And no, hold on. Let me hit refresh like that. And it'll actually show you what parts of your JavaScript and your CSS files that you are using and what you're not using. You can see up here we have like all this green is being used, all the red is not being used. And you can start looking at that to get ideas of stuff that you might not need to immediately load to kind of simplify things. Critical path CSS is, as I mentioned earlier, about loading the CSS directly within the head and loading the remaining CSS either before each component or just at the bottom of the body path. And as I said, like the way that works is your browser will be able to render the initial page, and that when it gets down to the CSS files, it will just, continuously render those, but your web page is actually displayed, so your user will hopefully be interacting with it. So less JavaScript, the better. Especially when you're using like server rendered stuff. On the web page I'm working on right now, we're not using jQuery. A lot of stuff you can get away with not using jQuery with modern JavaScript tooling without even, like, especially if you're using like server rendered stuff like Drupal does, you don't even necessarily need like React or Vue. You can just use kind of native vanilla JavaScript and get practically everything done. This is a funny thing I found. JavaScript main thread execution. Your browser will run all the JavaScript only on one CPU core. So your computer can have like all these CPUs, but only one person is doing the work. Your average website processing time for like 2018 is like, that says about 1700 milliseconds. That's like 1.7 seconds is how long it takes an average device to parse JavaScript in an average website. That's kind of bad. That's like almost 2 seconds that people are just like sitting there and your phone's sitting there doing nothing. Something that's like really interesting about this is like, look how fast the iPhones are. It's the iPhone 8 up there, at the very top. It's like, that's a lot faster. But not everybody has those. Most people have, the Motorola G4 right there. So you want to optimize your JavaScript. You want to identify third-party scripts. And we're a little over time. But I do want to show you optimizing third-party scripts right here. So let me show you that. I'm going to keep this under like 2 minutes. Let me go back to Sci-Fi's website, because they have just a bunch of them. So what I'm going to do is I'm going to go to the Performance tab right here, and I'm just going to hit this little reload thing right over here. And it's going to load up everything and eventually give us a trace that we can look at. And then what we're going to do is we're going to identify all the third-party scripts. So you can see how long this has taken. You can see that there's something coming in over here. I'm not going to go down everything. You can see how the yellow is JavaScript. This website is taking way too long to load. So the first thing I'm going to do is I'm going to go to the network tab, and I'm just going to type in -domain www.sci-fi.com. And so I can see out of this, like, 163 elements out of these are not from the website. 163 page requests, HTTP requests, are coming from domains other than sci-fi.com. Let's take a look and see what those are. The coolest thing, and this is relatively new within developer tools, is this little bottom-up tab right here. So this bottom-up tab shows you like what's using up the most time, and you can group things. So I'm going to group this by product. So immediately I can see that, like, all right, the regular web page is using like only 38% of the time, but look at Omniture. Omniture is using like 12% of the time. There's something else, a website called nervoussummer.com. I'm afraid to even go there. I don't know what it is. Chartbeat.com. There's some Facebook stuff. DoubleClick. Was it Moted? New Relic? All this stuff is being loaded right here. It's pretty crazy. You can also group by subdomain down here. Or actually, we'll just group by domain. So you can see, you can look at all this type of stuff. You can also, if you want to get like a little bit crazy, you can go into your network, and you can start blocking stuff. You can say, I want to block the request URL, and block the request URL, and kind of work your way down, or block request domain or something like that. And what's really interesting is you can kind of work your way down and kind of block everything. And unfortunately, there's no way now to block everything except for the source domain, but you can rerun your profile with and without the blocks, and then you can kind of see, well, hey, this is loading in 3 seconds without any third-party scripts, and it's loading in 6 seconds with third-party scripts. And that's a useful tool to take to like your marketing people who keep on dumping scripts into the page and stuff like that. So yeah, you want to make the web a better place. And thank you, since we're about out of time.